Hi guys, am I audible? Good morning, everyone. If you're able to hear me, give a response to the chat box so that I'll know that you have joined the session. Good morning, Usha. Hi, Vani. Good morning, Soumya. Only girls are turning up. I think the guys are still sleeping. Oh, Pranay. Good morning. Gaurav, good morning, guys. So you're able to hear an echo, is it? Is everyone hearing an echo? Okay. Just give me a minute. Is it fine now, or are you still hearing an echo? Is my audio still coming with an echo, or is it fine? Fine. Great. So let's start. So we have a very interesting quiz today. We have some good concepts to learn. So that's what I mean by very interesting quiz. So as usual, I'm going to start the quiz. Those of you who are attending the session for the first time, or those of you who are not students of George Prep, please visit the link that you have in the description. So there is a link in the description, the first link that you see, right? GeorgePrep/dashboard. So visit the first link and you'll be able to see a live quiz that's going to go parallelly to this session. So now I'm going to start the live quiz and come back to the session. The format is going to be, we are going to attempt one question, come back, discuss, go, attempt question, come back. So attempt, come back. That's how it's going to be. So I'm starting the quiz. Great. The first question is up. You can attempt it in the quiz. And it's up on the screen as well. You have 2 minutes for this. You can see the timing running on the screen for the first question. Okay, the time is up. And this is how the leaderboard looks right now. Let's see how we can solve this question. Once I discuss this, you will understand how simple the question is. Okay, let's look at the question now. Chandler went to a book fair, and purchased 20 tokens each of denominations rupees 3, rupees 7, rupees 11, rupees 25. If he has to purchase a book costing rupees 249 by giving exactly 14 tokens, then how many ways can he combine the tokens to get the required value for making the purchase? Okay, the key aspect here is, if you look at the token denominations that this guy has got, the denominations are 3, 7, 11, and 25. All are odd numbers, right? And he is supposed to give exactly 14 tokens, which means he is supposed to give even number of odd tokens. So if I'm going to add even number of odd numbers, I will end up with an even number. If I add even number of odd numbers, it will not only add. Let's say you take even number of odd numbers and you can connect them by addition, subtraction, anything. For instance, if I take, let's say, 4 odd numbers, you put plus or minus, it doesn't matter whether you're adding or subtracting. You put plus or minus in between them. If you have even number of odd numbers, the result is definitely going to be even. Okay, so 14 tokens would mean even number of tokens, and all the tokens are of odd denominations. If he is supposed to buy a book which is costing an odd value, which is 249, that's not going to be possible at all. The question is asking, in how many ways can he combine the tokens? In 0 ways he can combine the token. He'll never be able to combine 14 odd valued tokens to end up in a sum which is also odd. Answer for this question is none of these. Those of you are there in the live session, please type 4 if everybody is clear with why the answer is none of these for this question. Great, let's move to the next question. The next question is up in the quiz. And it is up on the screen as well. You can see the timer running on the screen. Well, the time is up. Let's see the status of the leaderboard. let's see how we can solve this question. If the square of 125 to the base b is 15625 to the base b, how many values can b take in the first 60 natural numbers? The key in this question is to realize that actually if I square 125, I will get 156. Okay, so you can put any value for b, it will satisfy as long as the digits here don't conflict with the value of b. Okay, let me give you an example by taking something very small. Let's say we have got 11 to the base b. Okay, 11 to the base b on squaring is giving me 121 to the base b. Now here we know that 11 on squaring in base 10 will actually give you 121, right? So but it is in base b, so let me expand this in base b. So if you have to expand this in base b, it will become 1 into b plus 1. So it's basically b plus 1. And when I'm squaring this, it is becoming like that, right? So I can say b plus 1 whole square is equal to, now this will become 1 into b square plus 2 into b plus 1. So it's going to be b square plus 2b plus 1. b plus 1 whole square is equal to b square plus 2b plus 1. Now if someone asks you, for what values will this be satisfied? This by itself will be satisfied for all values, right? Because b plus 1 whole square, the expansion is b square plus 2b plus 1. So this will get satisfied for all values, right? But given the kind of value that I have inside here, for instance, I have 1, 2 and 1, 1 and 1. Now, the relationship between the digits that you have and the bases, the digits that you have are going to be the reminders possible when a bigger number is divided by the base. That's how it works. For instance, let's say I want to write 15 in, let's say, base 4. If I want to write 15 in base 4, what we do is we keep dividing 15 by 4 till we get a number that is less than 4. So if I first divide 15 by 4, okay, it will be divisible 3 times. So I will get remainder as 3. Now I can say it is 33 to the base 4. Let's take another example. Let's say I have got 16 to be written in base 3. So what I do here, I'll divide 16 by 3. Quotient is 5, remainder is 1. Again divided by 3. Quotient is 1, remainder is 2. Now from here I'll have to take. So I can say 1, 2, 1 to the base 3. 16 when I want to express in base 3. It will become 1 to 1 to the base 3. So 16, if I want to convert into base 3, it will become 1 to 1 to the base 3. And why is it 1 to 1 to the base 3? Because those are the reminders that I'm getting. So you can notice, if you're writing something in base 3, you will never get digits which are equal to or greater than 3, because obviously reminders when a number is divided by 3 cannot be equal to or greater than 3, right? So given that fact, when I look at this, it tells me that any value can actually satisfy this particular equation. But given the kind of values we have here, 1, 2, 1, 1 and 1, b has to be greater than or equal to 3, because I have got 1 and 2 here. I hope this point is clear for all of you. Those of you who are there in the live session, can you please type 3 if you're clear with this point that I'm trying to make? Okay, someone wants me to repeat. I'm quickly going to repeat. See, in a particular base, the values that you have inside are basically the remainders obtained in that base. So if someone asks me, write 16 in base 3, this is in 10, base 10. If someone asks me to convert into base 3, what I would do is I will keep on dividing 16. So 16, first if I divide by 3, it's 5 times, 15 is perfectly divisible, remainder is 1. Again, I'm dividing 5 by 3 once, remainder is 2. Now to write 16 in base 3, I'll have to count from here 1, 2, 1 and then write base 3. So the values that you have inside in a particular base are basically the remainders obtained when a bigger number is divided in that base. Okay, so the values that I have here cannot be equal to or greater than the base, because the remainder obtained when you divide a number by, let's say, b, cannot be equal to or greater than b. So if it is given that 11 to the base b on squaring gives me 121 to the base b, I can first write them as an equation, and I'm getting like this. This equation by itself will be satisfied for any number, but looking at 1 and 2 here, I'll have to say b has to be greater than or equal to 3. Okay. So now let's come back to our question. Let me clear this one off. This we took to have some smaller numbers to understand the logic. Now let's launch into our question. The actual question that we have got here. So I realize I've got 125 here, 15625 here. It's actually 125 whole square, which means it's going to get satisfied for any values if I bring it down as an algebraic expression, right? So I could probably write it like this: b square plus 2b plus 5 whole square is equal to, from here on I have to start writing 1 into how many b's? b square, b cube, b to the power 4, 1 into b to the power 4 plus 5 into b cube, and so on. I can write till 5, right? Now this will get satisfied for any value. Why? Because 125 whole square is 15625. But I got to look at the values that I have got here. The largest digit that I have got here is 6. So b has to be greater than or equal to 7. It cannot be 6 or below 6. In that case, I won't have 15625. Right? So b has to be greater than or equal to 7. And they're asking how many values b can take in the first 60 natural numbers. So 7 till 60, or I can look at it like this: 1 till 6 it cannot take. Anything else it can take. So from the first 60 natural numbers, you subtract the 6. 60 minus 6, 54 is the answer for this question. Please type 54 if you're there in the live session, so that I'll understand you're very clear with this question. Great. Let's move to the next question. The next question is up in the quiz and on the screen as well. The time is up. Let's see what is the status of the leaderboard. Awesome, there's a lot of change. MSD Ashish at number 1 right now. Great, let's discuss this question. Consider 50 infinite geometric progressions with the first terms as 5, 6, 7 and so on till 54 respectively, and the common ratios as 1 by 6, 1 by 7 and so on till 1 by 55. Let S1, S2, S3 go till 50 be the sums of all the terms in the respective geometric progression. What is the sum of all the 50 sums? Okay, so we have got 50 infinite geometric progressions. Now first, how do we find sum till infinite terms of a geometric progression? It is a by 1 minus r, where a is the first term, r is the common ratio. But I've got 50 geometric progressions here. So let's see. So S1 will be first term, that is 5 of the first geometric progression, and the first common ratio is 1 by 6. So 1 minus 1 by 6. I'm just applying this here. So 5 by 1 minus 1 by 6, that is 5 by 6, which is equal to 6. Okay, now second one will be 6 by 1 minus 1 by 7, that is 6 by 7, which is 6. Now I already see what kind of pattern is going to come here. So 6, 7 and so on, 8, 9, it's going to go like that till I go for sum of the 50th one, right? So 50th term will be 6 plus 50 minus 1, that's going to be 56 minus 1, 55. So 6 till 55 I'll have to add. It's an arithmetic progression, right? Whole thing is an AP, they are natural numbers, serial of natural numbers from 6 till 55. So let's add them. I can take average of the first and last and multiply with the number of terms. So average of the first and last will be what? 55 plus 6 by 2. That's going to be the average of the entire series. Multiply by the number of terms is 50. So 61 into, I can cancel these two, it's going to be 25. 61 into 25. 61 into 25 should end in 25. If you look at the options, only one option ending in 25. That should be the answer. Now, if you're wondering why should this end in 25? See, whenever you have an odd multiple of 10 plus 1 into 25, it will always end in 25. For instance, let's take an example here. So if I take 41 into 25, I can take it as 40 plus 1 into 25. Now, if you look at this 40 into 25, there is already a 0. And this is an even multiple, right? So 4 into 25 will give me another 0. So this into 25 will give me 2 zeros, which means it is going to be a number like this plus 25. So that will end in 25. So 41 into 25 will end in 25. 81 into 25 will end in 25. 141 into 25 will end in 25. So 61 into 25 should end in 25. When I go and look at the options, there's only one option ending in 25. So that is our answer. Please type 3 if everybody is clear with how we solved this question. The ones who are there in the live session. Great. Let's move to the next question. The next question is up in the quiz. It's up on the screen here as well. Time was up. Great. There's some change in the leaderboard now. Mahendra Verma Simpran is on top, followed by Gaurav Jha, Rajalakshmi Rath, and MST Ashish. Great. Let's see how we can solve this one. If P and Q are natural numbers less than 13, how many distinct values can 10P plus 24Q take? Okay, first let me bring it down to the smallest form. So 10P plus 24Q, I can write it as 5P plus 12Q into 2. So let's find out for this. If I can get only 10 values for this, I'll get only 10 values for this as well. Right. So 5P plus 12Q. Great. Now, what all values can I get? See, I can actually try for a value. Let's say I'm trying for something like 70. Is that possible? Yeah. Q I can put as 5. And P I can put as 2. That gives me 70. Now look at the restriction given here. P and Q are natural numbers less than 30. Generally what we do is to find integer solutions. Now this is a concept that I've discussed in linear equations chapter, where how to find integer solutions for linear equations. So when we find integer solutions, what we do is we find out one set of value for P and Q. In this case, for P it is 2 and for Q it is 5. And to find the other values of P, we take the coefficient of Q, which is 12. So I'll have to add or subtract in terms of 12. To find the other values of Q, I'll have to add or subtract in terms of. Now the problem is, as we are looking at natural numbers less than 13, so we can only go from 1 till 12. When I have this 2, I cannot increase 12 or decrease 12. It's not going to be possible. Right? Because the numbers are limited to only 1 till 12. So I cannot increase it by 12 or decrease it by 12. So that tells me that for a given value here, like 70, if I could get an integer solution in terms of P and Q, that will be the only set of integer solution for the limitation that we have here. You won't find another set of integer solution. Okay. So what do we get from there? What we can get from there is they have given that P and Q are natural numbers less than 13, which means I could say I can put some 12 values for P, right? Starting from 1 till 12. Similarly, I can put from 12 values for Q. Now, the only thing that we have to make sure is none of those combinations give you the same result, right? I will get 12 into 12, 144 combinations for P and Q. But none of those combinations will give you the same result here, because as we have seen, for any result that you're going to get for our 5P plus 12Q, whatever is the result, there will be a unique combination of P and Q given this limitation. You cannot have one more combination of P and Q within this limitation, which will also lead you to the same result. Okay. So I can put any of the 12 values for P and any of the 12 values for Q, and each of those 144 will give you a unique result. Okay. So how many distinct values this can take? Answer is 144 for this question. Please type 144 if you're there in the live session, so that I'll understand that you have got the question. Great. Before we move to the next question, please make sure you like this video, because by the time we go to the last question, many people just push off without liking the video. So please do like this video. If you think that the session has been useful, it helps us to reach more people. Great. Let's move to the next question. Last question for today is up in the quiz. It's here on the screen as well. Well, the time is over. Let's see what is the status of the leaderboard. Rajalakshmi ended up on top. Congrats. Followed by Roshan, Mahendra Verma, Sipana, Gaurav Jha, Prakhya, and so on. Great. Let's look at how we can approach this one. If x and y, if x and y are real numbers such that y is square root of x squared minus 12x plus 32, find the range of values of x for which y is less than x minus 3. They have given x and y are real numbers. Now let's look at this part of the expression. Let me just change the color. Okay, let's look at this part of the expression. Y is square root of something and they have given x and y are real numbers. So if y has to be a real number, y is square root of something, then what I have inside the square root should be greater than or equal to 0. Otherwise, y will not be a real number, right? So I can conclude x square minus 12x plus 32 should be greater than or equal to 0 because y is a real number. The square of negative numbers will be imaginary, right? So this one, x squared minus 12x plus 32, I can write it as x minus 4 into x minus 8 greater than or equal to 0. So if I put them on a number line, so here critical value of x is 4, here the critical point is 8. So let me put both of them here, 4 and 8. Basically, I'm equating this to 0, getting the values of x. So 4 and 8. Coefficient of x square is positive, so the rightmost side is going to be positive. This is negative, this is positive. We are looking at when it will be greater than or equal to 0. So these are the ranges that I can take. I can take 4 and 8 as well because we are looking at greater than or equal to 0. Perfect. Now what? Y is less than x minus 3. Now let me take this y value and say it is less than x minus 3. That is square root of x square minus 12x plus 32 is less than x minus 3. So because I have an inequality here, I cannot just go about squaring both the sides, right? Okay, so what is the problem in squaring both the sides when you have an inequality? The problem is we don't know whether the signs of these things are both negative or both positive. Okay, so are they going to be one negative, one positive? We don't know about the signs. Generally, that's the problem that we face when you try to square both the sides in an inequality. We don't know about the signs. But in this case, let's see if we know about the signs or not. For instance, see, if I know about the signs, let's say I know that, or let's put it like this. If a comma b is greater than or equal to 0, means a and b are non-negative. If a comma b is greater than or equal to 0. And if a is greater than b, then I can conclude a square will also be greater than b square. If I know that a and b are non-negative, and if I know a is greater than b, a square will be greater than b square. And, if you want a proof for that, you could just look at the quadratic graph. So if you take the quadratic graph, the graph goes like this. Quadratic graph is what? Y is equal to x squared. So it's the square, right? So now from here on, from 0 onwards, if you see, the graph is quickly increasing. So from 0 onwards, when I increase the value of x, x square will also definitely increase. So if I pick up some two values of x here, such that this is my x1 and this is my x2. If x1 is less than x2, then x1 square will also be less than x2 square. Right. So that kind of tells you that if a and a comma b are greater than or equal to 0, if a is greater than b, a square will be greater than b square. Now let me just clear this one off. So if I know that they both are greater than or equal to 0, I could just square it and I don't have to do any kind of inversion with my inequality. So in this case, we know that this part is going to be greater than, this is not negative, definitely. Right? Square root of x square minus 12x plus 32 is not negative, because if that is negative, then this will not be real. So this is definitely not negative. It might be equal to 0, I don't know, but it is definitely not negative. Right? This is definitely not negative. It is at the least 0. And this value that I have on the right side is greater than what I have on the left side. So can I conclude that my LHS and my RHS both are greater than or equal to 0? Please give me a response if you're there in the live session. Type yes if I can conclude that both my LHS and RHS are greater than or equal to 0. Right? So once we know that both are greater than or equal to 0, we can happily go ahead and square both of them and retain the inequality as it is. So let's do that. Let's square both sides and retain the inequality. If I square both sides, I'll get x square minus 12x plus 32 less than, let's square this one also, a square plus b square minus 2ab. Okay, let's get rid of this x square from both the places. Now what are we left with? Minus 12x plus 9. Minus 12x minus 6x. So it will become minus 6x here. This plus 32, if it goes on the other side, it will become 23. So minus 6x less than minus 23. Or if I multiply both the sides by minus 1, I can say 6x is greater than 23 or x is greater than 23 by 6. Awesome. So that's some range that x can take. But we already have a range that x can take here. And this is the second range that we have got. Initially, we have fixed the range of x as it can be from minus infinity till 4, including 4, 8 till positive infinity. And this condition that it has to be less than x minus 3 puts another limitation on that, which is x has to be greater than 23 by 6. I will have to combine both of them to get my answer. Okay, where will this 23 by 6 come? 23 by 6 is slightly less than 4. Right? Let me just clear off this part. So 23 by 6 is slightly less than 4. So probably somewhere here it might come. Right. So from there till 4, because x has to be greater than 23 by 6. So from there till 4, so I can say 23 by 6 and it has to be greater than 23 by 6 till 4. And when I go for this side, 8 till positive infinity. Right. Okay. Now, any other limitations we have here? Can we include 4 and 8 or can we not include 4 and 8? In this case, can we include 4 and 8 or can we not include 4 and 8? What do you think? Twenty-three by 6 comma 4, 8 to positive infinity. Right. So in this case, can I include 4 and 8 or not? What problem we'll have if we include 4 and 8? Will we face any problem if we include 4 and 8? Doesn't look like there is any problem as such, right? We can have square root of 0 here, which will not be a problem. That will also give you a real number only, right? Now, if I include 4 in this case, let's see what will happen. If I include 4 in this case, if I include 4, this 4, if it goes inside this, if I put 4 here, there will not be any problem. But if I put 4 here, what will happen? This will become a negative value, right? But this will make the whole thing 0. But this thing will become a negative value, which can create a problem, right? If I put 4 here, this will create a negative value here, which can give a problem. So will 4 be okay or 4 not be okay? I think even if you put 4 here, this is going to make the whole thing 0, right? 4 minus 4 is going to be 0. And then you are going to go for this. So if I put 4 here, let's just see if I put 4 here, what will happen. So let's put 4 here. So if I put 4 here, it becomes 16 minus 12 into 4, 48 plus 32. That is 48 minus 48. That will give me square root of 0. Right? So if it gives me square root of 0, that is going to be 0 again. So it looks like we can include 4 here. So ideally this should have been like this then. Okay, so minus 23 by 6 to 4, and here you can include 8. Including 8 though, there is no problem at all. So union of this, that should be the answer for this question. Okay, type 1 if you're clear with how we got the answer as option 1 for this question. Great. With that, we have come to the end of our session. So we have seen some solid concepts in today's session, right? In terms of basis, in terms of fixing values for linear equations, what kind of values can come and so on. So tomorrow we will come back to discuss questions on paragraph jumbles without options. I'll catch up with you guys in tomorrow's session. See you guys. Have a great day.